Assalamu alaikum and good morning. Since in our previous lecture, that was lecture number third round, but that was not as numbering lecture number third, that was numbering actually as organic compounds, hydrocarbons, alkanes, alkenes, and alkynes. As in our previous lecture, that's hydrocarbons have furthermore subclassified into cyclic, cyclic and aromatic, and finally into number one, alkanes. We are discussing alkanes, which we are having general formula as CnH2n plus 2, that finally came n is equal to 1 equals to C1 equals to meth. Then after the formula became CH4, the number one, primer or the first compound of this family, and that named as meth. And according to alkanes, we should add then suffix "ane", that's methane, was the first of its compound formed. Then it was N is equal to 2, that was C2 is equal to H, means C2H, 2 3s are 6, S6, that became ETHANE, ethane. And then it was N is equal to 3, that was equal to C3, that means prop, and the formula became C3H8, means propane. Then N is equal to 4, means C4, means C-but. Then this became C4H, 2 4s are 8. Sorry, C4, it was C3H, 2 3s are 6, means plus 2 it was. Then this became C4H2, 4s are 8 plus 2, means C4H10, that is butane. And similarly, N is equal to 5, mean C5, that means pent, means C5H12, then this became pentane. And in the similar manner, when we say N is equal to 6, means C6 equal to hex, means C6H14, that is hexane. Similarly, N is equal to 7, that became C7, that is hept, HEPT, that is C7H16. This became heptane. And in the similar manner, this can be C8 in general, that's N8, C8, and that will become C8H18. That will become octane, oct, then add ane. then C9H20, and this will become nonane, and C10H22, and this will become decane. And for up to almost entrance level, we have to remember up to only 10th carbon atom, that's C10H22, this will become. And then after we will proceed further. जैसे हम अल्केन्स की जनरल फार्मूला करके उनके मोलिकुलर फार्मूलाज डेवलप करते हैं, in the similar manner this will become alkenes, Alkenes, and that will again be alicyclic, that's aliphatic, like this will become CnH2n, the formula CnH2n. Similarly, here we can again take n is equal to 1, that's equal to C1, that will become equal to C1H2, 1 is a 2, that is CH2, and this is not possible or not formed, as one carbon atom needs 4 single bonds attached to any of the molecules or within itself with any of its adjacent member, as we are discussing hydrocarbons, but there are only 2 hydrogen atoms and that can form only 2 bonds, as hydrogen has 1 its valency, therefore this is not formed. But from n is equal to 2, that will become C2, means F ETH, that will become C2H2 to 2 the 4, C2H4, and finally that will become ethane, ETENE, and similarly C3 will become prop, and that will become C3H6 propene. In the same manner, C4, this will become but, that will become C4H248, and that will be butene. Ene determines anywhere there should be the presence of carbon-carbon double bonds within the molecule, but this is discussion only about this one double bond within the molecule. And similarly, this will finally become up to decene, that is C10H220. This will be formula, and this will be furthermore when molecule will be opened anywhere will be dropped carbon-carbon double bond in the molecule. You should remember these things, and in the similar manner the aliphatic hydrocarbons will also be discussed in the form of alkenes, ALKYNES, and the formula is CnH2n minus 2. That will become again C1 is not possible, that's from the beginning molecule will be C2H 2 to the 4 minus 2 minus C2H2, the molecular formula will become C2H2. That is the molecule first formed will be ethine, ETHYNE, as we are giving the names on the basis of number of carbon atoms. C2 means eth, then we should apply somewhere carbon-carbon triple bond within the molecule, and the finally molecule will become ethine. Like there will be 2 carbon atoms, at least 1 triple bond should be there, and 1 hydrogen with this, so that 4 single bonds will be adjusted by this carbon, and then after by this carbon, and the molecular structure of ethine for this molecule will be like this. This will be called as ethine. Means Ine means carbon carbon triple bond is somewhere in the molecule. Similarly, another molecule will be C3H, means 2 3 is 6 minus 2, that will become C3H4. That is, there should be the presence of 3 carbon atoms and 1 carbon carbon single bonded, and one of the carbon carbons among the 3 should be triple bond to attach it with each other. Then after adjust the hydrogen atoms, the triple bonded carbon at the terminal will get attached to one hydrogen atom, and besides triple bond, the carbon carbon atoms, the other carbons which are attached by means of single bonds will get adjusted by the 3 hydrogen atoms. That means CH3 single bond C triple bond CH. Molecular formula will be formed for the propyne molecule. Yani this will become the formula for propyne, Propyne. And furthermore, we have to proceed for further molecules in case of alkynes as well as alkenes. In the similar sequence, we have proceeded up to 10 carbon atom for the alkenes. We have to proceed for alkenes and alkynes similarly, and anywhere we have to adjust carbon carbon double bond within the molecule in terms of alkenes, and carbon carbon triple bond within the molecule in case of alkynes. But before proceeding further, I will make you understand around another view, that's in terms of general representation for the general expression for expressing the different categories of compounds of hydrocarbons or some other organic molecules. Before that discussion, we should understand how we generate the generation of alkyl molecules. Alkyl molecules how generate or within the molecule, because that will help us in creating the general representation for any of the functional groups, for any of the more general representations for the any of compound category or any of the molecules. Like for example, we would say if there is our alkane that like methane, like C2H6 ethane, similarly C3H8, that's propene. Alkane molecules we should remember, because this will help us in many patterns. C4H, we should say 10, C5H12. Let's suppose we will subtract one hydrogen atom within each of the molecules like this. Just we have imagined this thing, we are subtracting one hydrogen atom. This is assumption purpose, this is supposition purpose. We have to subtract the hydrogen atom, otherwise within the reaction hydrogen atom gets attracted by some other thing and will get detached from the molecule, and the molecular formula then after will become CH3, and there will be attached single bond with it. As since simply we can say carbon is actually attached with 4 hydrogen atoms, like this is 1H, 1H, 1H and 1H. We are detaching only one hydrogen atom from the molecule. Rest of the 3 hydrogen atoms are within the molecule, and this single bond means this is the attraction between the attachment between the 2 electrons, one from the hydrogen and one from the carbon. We are detaching this hydrogen including this electron. That means one single electron is there. That means one single attachment this molecule will form. Furthermore, anywhere with anything to generate some other thing. And similarly, there we can generate what's called as CH3 molecule. And in the ethane molecule, we will subtract the hydrogen atom, this will become C2H5. C2H5, and we have to attach one single bond with it, means one electron is anywhere within the carbon atom, within the molecule, to get attached to something else. Similarly, there will become C3H7, means single bond attached to it. Similarly, there will become C4H9 and single bond. This will become C5H11 and single bond. Or if we open the structures of these condensed formulae like this, CH3 will become again CH3 single bond simply, but C2H5 will become CH3 same, and CH2. Then after we will detach one hydrogen atom from any one of the carbons, like this will become like this: CH3 single bond, CH2 single bond, means we have subtracted one hydrogen atom from the adjacent second carbon of the molecule. You shouldn't get here hindered. Why do we detach hydrogen atom from this carbon atom and not this? We whether will detach hydrogen atom from this carbon of this or this carbon atom, the molecular formula will become same, because such as if we detach hydrogen atom from this molecule, the molecular formula will become like this: CH2 single bond and CH3, as we have detached hydrogen atom from this molecule now and not this carbon atom. Therefore, this will remain the complete CH3 molecule, single bond, the fourth carbon attached to CH2, and this is the reversible form of this same representation. That means any of the molecules, any of the representations belongs both to this representation, that's ethane molecule subtracted by one hydrogen atom. In the similar manner, furthermore, hydrocarbon atoms, furthermore, these expressions where we are subtracting hydrogen atoms, we can represent these things like this will be represented as CH3 single bond CH2, then single bond CH2, and then after single bond. In the similar manner, as in case of this molecule, we have subtracted hydrogen atom from this carbon atom of the molecule, and in the similar pattern, when we reverse the molecule like this, the hydrogen atom is detached from this carbon atom now. In the similar manner, same thing will happen in this representation. The hydrogen atom will be subtracted from this or this carbon atom. That will become again the same reversible representation of the same molecule, and both of these things will belong to same category and the same molecule. That means these will express the same molecule in the similar pattern, and therefore finally this becomes alkyl, this becomes also alkyl. These subtracted hydrogen molecules from the alkane atoms, these become all representations, but detached or subtracted by one hydrogen atom from the parent hydrocarbons, that's alkanes, Alkanes. And these representations which are subtracted by one hydrogen atoms from the parent hydrocarbons, that's alkane, these are called as Alkyls. That means these are called as alkyls. Like CH3 will become alkyl, but carbon determines the name of the molecule. If it was methane molecule, that's methane, and when we subtract one hydrogen atom from this will become CH3 single bond. That is the name of this molecule will become meth, but we don't have to add then N of the molecule. We have to add now YL, means it will become methyl. Similarly, here this will become ethyl, ETHYL. Ethyl means this is the alkane ethane molecule, from where instead of N we have add il molecule. That means il will determine this is the parent detached, this is obtained from the parent hydrocarbon, that's alkane ethane molecule, but which is subtracted furthermore by one hydrogen atom, and this has become what's called as ethyl. In the similar pattern, for this molecule this will become propyl. Now you have to try to understand, as this is not being an explanatory class, I have to just bring around you the waves of the molecule, so that this will become easy for you people to understand these things. uh, you have to understand those things which I am making you understand in my what I should call say you. I should in my descriptive lectures. You can come to me and you can understand those descriptive lectures, or you can go somewhere that will make you understand properly these sequences. Similarly, this will become propyl, and this will become butyl, butyl. And here again, in the this is the condensed formulae. These are the condensed formulae I have created. These should be called as up to 10th molecule or something other. We can generate these all formulae, and these are called as condensed formulae. And here this will become C4H9. This is पेंटेन का मॉलिक्यूल सब्ट्रैक्ट बाय हाइड्रोजन जब करा जाता है, then this will become pentyl. In the similar pattern, we will open these structures, and these structures which are in the single bond form written as, these are called as open structures. Furthermore, this became propyl, and then after this will become like this: CH3, single bond CH2, single bond CH2, single bond CH2, means this will become butyl. And furthermore, discussion butyl, pentyl, something, etc. But from butane molecule, that's butyl, where it becomes from here there arises some what's called as some another discussion, what's called as isomerism, and that will be discussed inshallah in our next lecture, and we'll discuss that inshallah in our next lecture. Until goodbye and assalamu alaikum. Khuda Hafiz.